and it does not melt at all. That from 140 to around 200 250 degrees, no, still it will become sticky and stringy and so on, a little like some of our food materials we see. So, calling it resin, I am not very what you call comfortable with it, because all plastics are resinous plastics only. So, now if you see here, multiple options have given, white, black and transparent. So, this picture here, no, he has printed that their thing logo there, and then you see here, I think it is a clip of some sort, I am not very sure. If I come to shocking thing, saying made of stainless steel. Now, can we actually print things in stainless steel? Is it a wire that is woven, or what is it that is done? This I was telling you, it looks like the military uses directly powder metallurgy or sintering process, by which they are able to make things absolutely but you see that what is $1 there, it is 4 to 5 times here, but you have beautiful things. It looks like a branding stick, or of course here it is actually a cuff link. So, made with multiple steps, coloring option like gold and bronze plating, 6 layers for 1 millimeter and very thick. As we go down, now they say even gold and silver can be printed. So, right, you have a nice map of the United States, and you see where the thing is radiating from, that is maybe where their company is situated, or where the world power is situated, or anything. So, you see here made from lost wax process. So, I am not very clear how it is used in 3D printing, but this lost wax is traditionally how jewels have been made. So, I will skip this and just leave it there absolutely. Similarly, we have titanium direct metal laser sintering, that is you have a powder and then a laser prints everything, and then you have beautiful objects like this which are printed here. And as we go down here, ceramics are also available. First ceramic is printed, then surface is glazed. So, expect the ceramics also come as a what do you call as a filament. I am sure some of you have noticed it in it. Ceramic can also be 3D printed by, it will be extruded as a round this thing all around like this. It is not exactly 3D printing. I will say if I can locate the what do you call thing here. When I tried to look at it a little while back, I could locate it. Now, please look at this this thing. Unfortunately, I have no audio. Just watch the video feed as it comes. So, when you get a chance, please go back to your computer and try to see whether you can see this. This whole thing is printed by using a 3D printer, just like you have a, in our case it is a small what do you call sorry, the yeah, it is actually ceramic. After printing it, any texture, anything.
before we then put it into kiln and fire it. That's known as a biscuit firing, the first firing. And at this stage, that's where it becomes same as a normal ceramic process, because you would have a biscuit firing in ceramics. So we biscuit firing to a temperature and then take it out of there. You can then glaze the object and refire at a higher temperature for the glaze to go over the ceramic object. And then you can have a third firing if you decorate, where you refire the decoration on top. But you will always have at least two firing. In terms of timescale of seeing 3D printed ceramics being commercially available, I think you have to remember that this is a research process, and even though we've worked with Denby, got a much further level, it isn't yet really very commercially available.
This of course was an old this thing. I understand now these days now several people, especially what you call hackers, have been trying and creating really beautiful objects. The thing here is you work on the 3D model and then somebody else does everything, and then what you want is automatically done. So 3D printed ceramic ware outside the table are all very good. In probably after the after this section is over, I will try to come back to stuff used in medical, including teeth, including bones. Probably we have which are very much possible for us. I suggest you just go to the
I suspect the way the technology is going at the higher end, much like our technology, it's too expensive to be a home.
so as I said, no, it's expensive. But in the end, less talking and you are out with beautiful 3D printed objects. This is the one. So what I was waiting to show you this. It's a little commercial item, but still, no, I feel it's worth that you should watch. Like all other 3D printing, it starts with a base. Except the small thing here is, if you see carefully, you see how the X and Y stuff is moving. Full table doesn't move. They just have two. I do not know whether it is a caster or actually they are special wheels, and the clay extruder extrudes at a constant pace, and only Z axis is controlled by it, and it rises slowly. Have a look at it. We have full-fledged ceramic tray being printed. Can life be better than this? So, I will just advance it a little, and then after that at your leisure please go and see what best you can make out of it, and see anything you can think of you can make it. So, what I will do is I will probably now stop here for a short while. I have introduced you to most of the materials, including all the what all certain things there are engineering objects meant solely for engineering purposes, including, if you remember, I showed you the oscillating mechanism, the fan, you had the gears and all that. Then I shown you a sample of a small box which fits on a very tiny printed circuit board and is used for a DC-DC converter. Then I showed you a potential that things like this fans can be made, and of course I did a goof in showing the wrong direction of the fan blades. So, if you are to take a fan like this, let me show something which is easily visible, kindly show. If you take a fan like this, it is not enough if you just reverse this plus and minus, because the direction of this when it gets reversed, it is not at all efficient. So, in those cases probably if you want to make a fan which is there, obviously the easiest way is to reverse the fan. Alternately, you have to make a fan profile which has some attack angle and all that, which is symmetrical, works on both directions. Alternatively, where such things come, let us say I have a fan which has a common axis. I have one fan here and one fan here, both are rotating in the same direction. You understand, common axis, impeller here, the impeller rotation is same. And why I cannot afford to use two fans like this? Problem is, if I put two fans like this, they will not ever run at the same speed. So, they usually have a common axis, a motor or something like that. Now, the common the rotor is rotating at one direction. So, I need one where the air is being sucked in here, and from here same thing, the air is being sucked in here and has to be blown together. That makes sense for things like exhausts, and then maybe your more sophisticated thing, typically where you cannot afford to have two fans running independently. Usually you have a common shaft and then you have this running, and in the case of a large thing like our turbine, we take a huge turbine, it runs in 13-14 stages, each of them does a small thing about it. In between they have got some correction and all those things. Those things models can easily be printed using our nothing, I am fascinated by this. I will close it, otherwise I will get stuck in these prints. Just before I wind up for this particular thing, before I go to the medical or the bio stuff, I wanted to suggest, have a look at these things which I am continuing. You see here, this is, I do not know whether it is hype or the future. Honestly, I do not think food is yet ready for that. Printers are being developed every day to print all sorts of materials, from plastics, metals, composites, concrete to organic materials, paper and even food. Last part I will avoid because somehow it does not taste the same, but in some conditions probably it does make sense. Let us say you are making decoration for cakes, or usually that sugar molds or sugar candy from which most of the cake exhibits are made. Such things are best printed by 3D. Nobody needs to go on taking all that sugar and trying to make sheets and stick it and all that. The whole cake decoration can probably be printed using some sugar thing, and printing a cake decoration, especially starting with your name. Your means not yours, your dear child's or your partners or your good friend's name, using biologically digestible materials is not very far away, it is easy. If you remember cotton candy is nothing but molten sugar. Molten sugar, when it is it's whirled at very high speed, that strands come out and they feel like cotton, and it's what you call wound around a stick, and then you have it a little like that. Instead of the strands coming at high speed using centrifugal force, you can probably extrude those things and print anything which is typically a cake decoration or any cookie decoration or anything. Now coming back to cookies, cookie dough can easily be printed, is it not? You need not take all the trouble of first rolling it flat and then taking a cookie cutter and making varying shapes and all that, no. Instead, imagine you have a 3D printer at home, and then you want to, whatever it is, you can make a decoration, and you can actually print it. Later on you put it in the oven, and then you have cookies of any shape you like, and so it is real. You can think of the various options. Now if you kindly look at the I mean the thing here, first of the thing you will notice is, now these days it is a hot and exciting field. Product developer began with those currently in use, undergoing testing, and are followed by materials of interest in other fields. First is, so below are his top 10 favorite materials for 3D beyond common and improved plastics, starting with current ones. This is a very interesting thing, used for printing injection molds and sacrificial fixtures that accelerate the design process for traditional manufacturing. You print the lattice and lay out the carbon fiber around the mold, then you put it in a bath and the support material melts away. So you see here, sintered powdered metal is typically something which is used. So it is a combination of part of the traditional workshop or the machine shop things are replaced by this type of options. Sacrificial fixtures that accelerate the design process. Okay. One of the applications is for carbon fiber layup. To do the winding or anything, no, you need a former. You make this former, and then after that, no, you do with it. You print the lattice, lay out the carbon fiber, put it in a bath, the support material melts away. Next comes stainless steel, bronze, steel, gold, nickel steel, aluminum and titanium. Printed directly by binding metal dust and firing it to become a hard part. Process can replace casting and post processing and turn material directly into a functional metal part that can be electro-polished or machined to finish the items. Prototyping is the best example of this application, but also being used for medical devices, jewelry and custom items. So that next lecture will contain. Then carbon fiber and other composites. A 3D machine first prints a plastic like ABS and then prints carbon fibers on top. It is more cost effective and accurate to print something as stronger than metal. It can be scaled up. Printers are small. I see it replacing carbon fiber layup, a slow and time consuming process used in bicycle and aeronautics industries. Then carbon nanotubes and graphene embedded in plastics. The most awesome is graphene. This is all promise of graphene. Its amazing strength, conductivity instead of connectivity, its size. You could make things like flexible touch screens, solar panels and building circuits made of extremely tough materials. That is the only material I have seen where you create totally new technology, not just being able to do stuff faster or easier. This is something totally new. Said no, beyond this I too have not done it, and maybe there are publications and so on. Next, I am reading it along with you first time. So titanium nickel alloy, they have called it nickel titanium alloy, lot of medical implants. This metal has amazing properties, super elasticity and the ability to change shapes. For catheter wires and stents, can bend further than anything else. You can fold it in half and it will come back to its original shape. Because the metal is not an easy material to machine or create a lot of different forms. 3D printing allows you to do things with medical products you couldn't do before. Water absorbing plastic is printed using a 4D printing. I have no clue what it is. If something is being inserted into the body, in a narrow tube, but the end product needs to be different shape. The object can transform itself after it is inserted. It happens often now, right now, with several types of stents which are all inserted into the, you too must have seen the, what do you call, the, actually it is a simulation, I do not know if it is real or, it is just an animation. You introduce something into a artery, and then at the end, it expands the artery, and then it breaks up all the whatever sclerosis that happens, and all the material is sucked out using a vacuum like devices. Such that device at the tip is probably made with this water absorbing plastics. So, as you insert it probably the material is held together, but after it is put in place, it will make it. So, if you click on this, we will do it later. Then being able to print organs to replace an ear, a blood vessel, or a piece of the heart is not just amazing, is a pretty amazing dream. So, right now there are one or two startup companies which are doing it. If with their permission, maybe I will be able to show you something later. So, there they claim that they are able to print cells like what you have. So, I too am impressed by what they can talk about. So, after I pass this, after a little while, after I finish this 10, I will come back to this. I have the link on my mobile, I will show you. 3D printing allows circuits and batteries to be built into plastic parts used to make devices. It would eliminate some assembly, leading to additive manufacturing replace most if not all other manufacturing process. There are very few plain plastics or mechanical parts these days, everything is electromechanical. See the critical thing, if you have a shape memory alloy, you imagine you give a voltage and things change shape and so on. It is a little slow at the moment, but in the large time this morphing can easily be done if it is conductive. Next paper, Synthus. Not long ago, if you remember, if you see a map has small lines which is printed over it with some numbers printed on it. They are all what you call a trace of points of the same height. So, surveyors used to plot these maps. Now, if you take any of those what you call iso lines and then cut cardboards according to it and then print one over the other, very easy to make what look like regular landscape models. So, this material information which is already available was used to make layered thing. So, right now layers of paper is very thin, that those things are made with usually foam core board, and in case you can cut paper, very beautiful things can easily be made. Now, the last one which stops here is so you see there. So, you have really interesting things here. Just keep reading it. I am searching on my mobile for the link of one of the startup companies here, which yeah, it is called nextbiglab.com. Let me try if it works. It's that their servers and all are a little slow. This is right now, since it is public information and it is directly hosted, I have not taken any special permission from that. So, if it what do you call, if it comes, Synthus, next big innovation, if you go down, we are a 3D bioprinting company based in Bangalore. We proud Make in India is to create organs within a laboratory using something about 3D bioprinting. Expertise in 3D printing, biotechnology and pharmaceuticals. So, I want you to have a look at it yourself. It is not yet ready. So, I still feel it is still in the incubation and so on. So, at your leisure we have surgical models, have a look at it here, and then we have scaffolds using novel materials, and then bioprinters. So, this stuff, pre-surgical models, this is considered the next innovation, a big innovation to get maxillofacial surgeons, dentists and orthopedics people. Not long ago, orthopedics is only considered, I mean, on two different, completely different, thing. One is purely structural, meaning you have these, what do you call, I mean, various type of stirrups and things which are used to see physically deformed people, they are born or by accidents or anything. So, what are called calipers, are seen. You would have seen children wearing calipers, and people, accident victims, have some things, which are holding these jaws and all that. Now it looks like this company, in probably in collaboration with somebody out there, which I do not know. Okay. So it is now offering these things, okay, including 3D printed tissue assays. Okay. We provide researchers a robot research methodology comprising a 3D printed tissue assays and an indigenous bioprinter, so on and so on. So I expect skin tissue, first of its kind, has been developed using and so on and all that. So it is possible now, whatever you want you can do it, but right now no, do not take too much of it. No, I will not show you the people, have a look at it. It is not very far away in which time we can create stuff in printing. So the issue is about two parallel things. One is how to adopt the technology. In the case of ceramics, we are printing the formers and all that and directly firing them, and in the case of these what you call biomaterials, it is slightly different. So next one full session I would like to take only on biomedical and biology related things. So thank you, as of now, thank you. Let us see again and see if I can get back, and if I can get my what you call contacts there in that lab to at least give a presentation, probably we are better off. So thank you.